Myself, Dr. Dipak Gapale, Assistant Professor, Department of Physics, Sangamner College, Sangamner. Now, in previous video, we discussed Cartesian coordinate system. So, in case of Cartesian coordinate system, we need three coordinates to represent the position of any object in a three-dimensional case. So, these three coordinates are x, y, z. Now we in this video we discuss now then transformation equation between spherical polar coordinate system to Cartesian or rectangular coordinate system. Now here we can see, so this is x axis, this one y axis, and this one is z axis. Now here the P is the point P. Now here point P, from the origin the distance of point P, that is your coordinate r. Now then if we take the projection of OP on xy plane, its projection is OQ. Now from Q point, if we draw perpendicular on x axis, that is ON, that it gives your coordinate Cartesian coordinate x. Now if we draw projection on point P on y axis, it gives your coordinate y, and this is your z coordinate. So those are the Cartesian coordinates. Those are the Cartesian coordinates. Now in that case, in this Cartesian coordinates, spherical polar, so distance O to P, that is coordinate r, this angle is theta, that is a polar angle theta. Now this polar angle theta is our second coordinate, spherical polar coordinates, and this angle phi is our third coordinates. Then if we now here the coordinate x, y, z, Cartesian coordinates, x is equal to your ON or QM, y is OM or NQ, then z is PQ or OZ, like that. Those are the coordinates. Now then the coordinates are theta phi are spherical polar coordinates, r is OP, theta is angle ZOP, then phi angle is what, NOQ, like that. Now these are the spherical polar Cartesian coordinates in terms of spherical polar coordinates. So if we take x, the coordinate x, now the coordinate x is what, ON, and here ON is what, OQ cos phi. Now ON, we want to find out ON, so this is the right angle. Now with this right angle, here this angle phi, the adjacent side of phi angle is what, x. Therefore, if we take sine of phi, sine phi is equal to what, ON divided by OQ, hypotenuse OQ. So this angle phi, sine phi ON, opposite side, here opposite side is NQ, sorry, QN, opposite, sine phi is what, opposite side divided by hypotenuse, so it is what, OQ divided by N, that means OQ is your y divided by QN is y divided by OQ. This implies y is equal to OQ sine phi, OQ sine phi. Now if we take cos of phi is what, adjacent side divided by hypotenuse ON, adjacent side is ON divided by hypotenuse OQ. So this is equal to x divided by OQ. Therefore x is equal to OQ cos phi. OQ, we can take OQ in that side, so x is equal to OQ cos phi, and here OQ in that side, y is equal to OQ cos phi. In this way, now then OQ, we want to find out this OQ. OQ is what, this OQ, or this is nothing but what, your ZP. OQ is nothing but ZP. Now if we take the sine of theta, sine theta, so sine theta is what, opposite side ZP divided by ZP divided by OP. So OP is R, and ZP, Z into P, that is nothing but your OQ. This implies OQ is equal to R sine of theta. That means this OQ is R sine theta. So first coordinate x is equal to R sine theta cos phi. So similarly, we can get the second coordinates y is equal to OM or OQ sine of phi, and OQ is what? R sine theta. Therefore y is equal to R sine theta sine phi. Then Z. So Z is what? Adjacent side of this angle theta, and this is what? OP cos phi, and OP is your R, coordinate R. Therefore Z is equal to R cos theta. So these are the transformation equation. That means x is equal to R sin theta cos phi, y is equal to R sin theta sin phi, and z is equal to R cos theta. So those are the transformation equation between Cartesian coordinate to spherical polar coordinates. Now the transformation equation between spherical polar to Cartesian coordinates. So for that, first, that is R, which is equal to x square plus y square plus z square. So this can be very easily obtained. We know that x is equal to R sin theta cos phi, y is equal to R sin theta sin phi, and z is equal to R cos theta. Now if we take the square of this and then adding x square plus y square plus z square is equal to R square sin square theta cos square phi plus y square, that is R square sin square theta sin square phi plus R square cos square theta. From these two terms, if we take R square sin square theta common, so we can get which is equal to R square sin square theta in bracket cos square phi plus sin square phi, and cos square phi plus sin square phi is 1, plus R square cos square theta, R square cos square theta. So if we take R square common, then sin square theta plus cos square theta is 1, so which is equal to R square, and by taking square root, R is equal to square root of x square plus y square plus z square, like that. So those are the transformation. Then theta, so theta is equal to z, z is its adjacent side, cos theta is equal to z divided by r, and r is this. So in this way we can get the relations. Theta is in terms of Cartesian coordinates x, y, z, and phi is equal to tan inverse of y by x. Okay, so in this way we can write the transformation equation between Cartesian coordinate to spherical polar coordinates. Now then, volume element in spherical polar coordinates. So for this volume element in spherical polar coordinates, now the coordinates are, this is the coordinates, OP is r. So increment in r, coordinates are, increment in coordinates are, that can be represented. So here is r, increment in r, that is dr. This is the increment in r, edge increment in r, r increasing in that direction. So this is dr. Now theta, so this is angle theta. If this angle theta change by a small angle d theta, so this change is over this arc PS, arc PS. Now then the angle phi, so this is the angle phi, and the increment in angle phi, we can represent this increment angle phi, that is d phi. So this increment is over this arc, and we want to find out the length of this arc. So the length of this arc can be obtained. So now in that case, if we take sine of d phi, sine of d phi, so sine of d phi, its opposite side, that is PS divided by r. So r is your OP, that is hypotenuse. Now here this d phi angle is very small, So sine of d phi is nearly equal to d phi, so that d phi, which is equal to ps divided by r, this implies arc ps which is equal to r d phi. So arc ps is what? R d phi. Now this arc, that is nothing, this arc, suppose we put this as AB, arc AB. Now here if we take the sine of now here is d theta, not d phi, d theta. Now sine of d phi, which is equal to, so AB divided by OA, AB divided by OA. But this OA is nothing but ZP, and we want to find out the ZP, which is R sine of theta, R sine theta, and this one is AB. So as d phi angle is very small, so sine of d phi is nearly equal to d phi, which is equal to AB R sine theta, AB R sine theta. This implies AB which is equal to R sine theta d phi, R sine theta d phi. This is arc, AB arc. Now here is this AB arc. Okay. Now here, that means these are the three sides of cuboids. So this is dr, this one is what? rd theta, and this side is what? R sine theta d phi. So that the volume of this volume element in spherical polar coordinate system is dv. dv is the product of this, that means dv, which is equal to dr into r d theta into r sine theta d phi. So this is equal to r square sine theta, d r d theta d phi. So this is the volume element in spherical polar coordinate system. So thank you for watching.